Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello and welcome back to this video series on right triangle trigonometry. You should have already watched the video that I have on triangles and special triangles and trig. Specifically for this video, you're going to need that. And you should already know what trigonometric functions are, at least from the previous video. Now, we're going to go ahead and use our previous information to evaluate trigonometric functions at the special angles. Not all of them, but just some of them. And as I mentioned in a previous video, whenever you're going to do any type of work on trig, it's probably a really good idea to just draw out your special triangles. So I'm going to draw out my pi over 6, pi over 3 triangle. And remember, that's 30 and 60. And then I'll also draw out my 45, 45, 90, which is pi over 4 right angle. And I'm going to zoom in to fix that handwriting too. And it still looks like not that great. Anyhow, this is 1, this is 2, this is root 3. This is 1, this is 1, this is root 2. That's how I write them. I know that everybody's a little bit different. All right, let's go ahead and do this. Evaluate all trig functions at 30 degrees. Okay, so I want to know the sine at 30 degrees. I want the cosine of 30 degrees. I'll need the tangent, again, of 30 degrees. All of these at 30 degrees, basically. And then same thing for the cosecant and the secant and the cotangent. So that was just a setup. Now we're going to go ahead and reference our triangle here. This is the 30, 60, 90. Specifically 30 degrees is pi over 6 radians. And sine is going to be opposite over hypotenuse. So 1 over 2. So sine of 30 degrees is going to be 1 over 2. Its reciprocal is the cosecant of 30 degrees, which will be 2 over 1 technically. And now we'll go ahead and go to the cosine of 30 degrees. Cosine is going to be adjacent over hypotenuse, which is root 3 over 2 there. So let's go ahead and fill that in. Root 3, write that down, over 2. And then the secant of 30 degrees, well, that's going to be the reciprocal. That's 2 over root 3. And as I said previously, I don't bother rationalizing denominators. And finally, the tangent of 30 degrees, that's going to be opposite over adjacent, 1 over root 3. So let's go ahead and write that in here. 1, let's see, where am I? 1 over root 3. And of course, cotangent is the reciprocal of that, root 3 over 1. Now, I should be very honest here. Several of these are memorizable. I would not memorize, normally don't memorize cosecant, secant, or cotangent, but I definitely memorize the sine and the cosines. Sine of 30 degrees, I just know quickly, 1/2. Cosine of 30 degrees, I know pretty quickly, root 3 over 2. It really does help to be able to just write out that triangle though. So if you don't memorize it, at least you have the triangle next to you. The next example here asks us to evaluate all the trig functions at pi over 3. Basically using that same triangle. Again, I'm just going to draw it out just for practice, right? So pi over 6, and this would be pi over 3, and right angle. 1, 2, and root 3. All right, so evaluating all the trig functions at pi over 3, let me at least write the trig functions down. So we have that all written out. And now I'll just reference my triangle here. Sine will be opposite of pi over 3 over the hypotenuse. So that'll be root 3 over 2. Let me write that in. Square root of 3 over 2. And of course, cosecant is its reciprocal, so that's 2 over root 3. That should look familiar. let's see, cosine of pi over 3. Well, cosine is adjacent over hypotenuse, so that's 1/2. So I'll write that in there, 1/2. And of course the secant is its reciprocal, which would be 2. And then finally the tangent of pi over 3, opposite over adjacent, which will be √3 over 1, or √3. So I'll write that in here. And of course cotangent is the reciprocal. Now something I want you to notice here, a critical thing to notice actually. So pi over 3 is 60 degrees, right? So pi over 3 is the same thing as 60 degrees. And we just finished in the previous problem looking at the sine, all the trig functions at 30 degrees. Let me hop back and show you. Here are all the trig functions evaluated at 30 degrees. Notice the sine of 30 degrees is 1/2 and the cosine of 30 degrees is a √3 over 2. Now we're back at the newest problem, and notice that the sine of 60 degrees is √3 over 2 and the cosine of 60 degrees is 1/2. Again, I wrote it down below just so that you could notice here, but it turns out there's an identity that we're seeing here. Notice that the sine of 60 degrees is the same thing as the cosine of 30 degrees. And the cosine of 60 degrees is the same thing as the sine of 30 degrees. The tangent of 60 degrees is the same thing as actually maybe I should use a different color here. The tangent of 60 degrees is the same thing as the cotangent of 30 degrees. And the cosecant, or maybe I should say secant of 60 degrees is the cosecant of 30 degrees. What we're stating there is something called the cofunction identities. And we'll deal with those in another video, but it's just important to know that there is a relationship between the sine of 60 and the cosine of 30, the cosine of 60 and the sine of 30, and so on and so forth. And we will make that relationship more apparent once we get into the next video. But for now, I just wanted to point it out that those numbers are going to be hauntingly familiar as we move forward. What about trig functions at pi over 4? We haven't done those, so let's go ahead and draw out a 45, 45, 90, or a pi over 4 right angle triangle. And if you haven't noticed, I always use 1 for the smallest side. That's where my 1s always go, is the smallest side. And when you're dealing with a 45, 45, 90, well, both sides are the smallest. So there you go. Evaluate all trigonometric functions at theta equals pi over 4. Well, let me pre-fill a table for us. Now that we have that done, let's go ahead and just use the opposite over hypotenuse for sine and start up. Right, so sine is opposite over hypotenuse. Notice I could have chosen the other pi over 4. It doesn't really matter. So opposite over hypotenuse, though, is 1 over √2. So let's go ahead and do that. 1 over square root of 2. And therefore, the cosecant is square root of 2 over 1. The cosine of pi over 4, well, that is adjacent over hypotenuse. And, of course, that is 1 over √2 as well. So 1 over √2. And again, its reciprocal is √2 over 1. The tangent's kind of the easy one of the group. Tangent's opposite over adjacent, 1 over 1. And so we will go ahead and write the tangent of pi over 4 as 1, and the cotangent of pi over 4 as its reciprocal, which is also 1. And there you have it. These are the permanent values for the trig functions evaluated at pi over 4. And that is important to state. These are all like the values of these trig functions. So sine of pi over 4 is nothing more than 1 over √2. And tangent of pi over 4 is nothing more than 1. So from this point forward, that's what those are. You don't need to memorize those. It's the right triangles that are really memorizable. Now, what is trig without applications? It's basically useless. So let's go ahead and do an application. This type of problem, although spelled out and not given a picture, is very typical in a trig course. Normally they give you a picture though. So I'll help out by drawing a picture of this. Allie is directly west of her friend Becca. West is that away. Okay, Allie is directly west of her friend Becca. They are 500 feet apart on opposite sides of a river. Downstream and on the same shoreline as Becca is their raft. Assuming the raft is directly south of Becca, and Allie knows that the angle between Becca and the raft is 30 degrees, find the distance Becca must walk to get to the raft. That sounds like a lot. It's actually not too much. Let's go ahead and label this point A for Allie. She is directly west of her friend Becca, so we'll name that point B. And directly south of Becca, but down shore, is the raft. I'll call that R. Okay, but it's directly south of Becca, and Allie is directly west of Becca. There we go. I hope that makes sense. Allie and Becca are 500 feet apart. And let's see, anything else downstream along the same shoreline as Becca is their raft, assuming the raft is directly south of Becca. And then that the angle between Becca and the raft, what I mean by that is this angle right here, from Allie, as she's staring at Becca, to Allie staring at the raft. That angle right there is supposed to be 30 degrees. Yes, I know, it doesn't look like 30 degrees. That doesn't matter, it's just a drawing. We want to find this distance D. Okay, we could totally do that. The first thing I'm going to do, because I see a 30 degree angle, is I'm going to redraw my 30, 60, 90. This time I'll actually use degrees. 30, 60, and 90. 1, 2, and root 3. The one always opposite the smallest angle. All right, so in this case, let's see, they gave us something. We want to find that distance. Well, okay. What trig function? Now, this is a common question you're going to be asked. What trig function relates this angle right here that they handed you to the unknown side and the given side? That's really the big question. Let me actually write that down. It's so important. There you go. So what trig function relates the given information and the unknown? Well, if you look back at your trig functions, your trig definitions, there are two actually that relate those things. Remember, 30 degrees, you're dealing with an opposite and an adjacent. And if you look at all your, that's supposed to be 80J, but it just didn't work out for me. If you look through all of your definitions for your trig functions, tangent gives you the opposite divided by the adjacent. Yes, cotangent does as well. Totally get that. It gives adjacent over opposite, but I would rather deal with tangent if I could. So I know that the tangent relates those. So I'm going to say the tangent of 30 degrees should be opposite, which is D, divided by the adjacent, which is 500. Now notice I have an equation that has D in it. And I happen to be able to find tangent of 30 degrees, not by switching back to a previous page and looking for my previous work, but instead by just looking at this page and my triangle off to the right there. The tangent of 30 degrees, opposite over adjacent, is 1 over root 3. So D will equal 500 times 1 over root 3. Remember, the units for that 500 are in feet, I think. Yeah. So it's feet. And then, of course, because this is an application, they probably want us to go ahead and solve, like approximate that value. So I have a calculator in my hand right now, and that is approximately, when I'm rounding to maybe a single decimal place, 288.7 feet. So the distance from Becca to that raft is around 288 feet. Maybe 289 feet south of her. So that's a good application. There's a ton of uses for trig, but I reserve most of the applications for a completely different video. I just wanted to use this one to kind of get us used to working with trig functions. But from this point forward, we'll probably approach, actually not this point forward, but in a couple videos from now, we'll do a whole bunch of applications. All right, that's it for this. The next video is actually on cofunction identities, and then we'll get into applications.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles. obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.